negative exponents. So, here's what I want to make sure by the end of this video you get. So let's start at the end. By the end of the video, I want you to have this figured out. Write this down. Stop the video after I write this. Write this down. Write this down 10 times. Say it out loud. Chant it in your sleep. Yell it out the bus window. Carve it into, but not carve into trees. Write it in your snack. Do something. Negative exponents cause fractions, not negative numbers. That is to say, negative exponents do not cause negative numbers. Say it again. Negative exponents do not cause negative numbers. I didn't say that they erase negative numbers or that they can't be associated with negative numbers, but they don't cause them. They cause fractions. They cause things to be rationalized. They cause reciprocals. Somebody's going to argue with me. Go for it. I mean, I'm dying to hear from you. I truly am. Let's really have this thing talked out. Let's start with kind of this idea. Maybe this. Let's do this. 5 to the first power, 5 to the second power, 5 to the third power, 5 to the 0 power, 5 to the negative. Wow, that's neat. That's something new. 5 to the negative second power, 5 to the negative third power. Let's go with some stuff that we know. Hopefully we know that 5 to the first power is 5. Hopefully we know that 5 squared means 5 times 5, which means 25. And from there, this would mean that 5 to the third power is 5 times 5 times 5, which is 125. Let's go to some backwards math here. 25 divided by 5 is 25. 25, right? We multiply by 5, so now we're just going to divide, go backwards, right? 25 divided by 5 is 5, and 5 divided by 5 equals 1. That's interesting. 1 divided by 5 is 1/5. 1/5 divided by 5, 1/5 divided by 5 is equal to 1/25, isn't it? So 1/25, right? 1 over 25 divided by 5 is 125. Interesting, right? So maybe you're like, well, that's kind of weird. It's strange. Let's look at it this way. And ask ourselves, under what circumstance could we end up with a negative exponent? So when do negative exponents occur? And let's see if we agree. Let's start with this rule that hopefully that you've learned in algebra, and that these second rule of exponents, usually at x to the m divided by x to the n is equal to x to the m minus n. This m is this m. This n is this n. And look, these x's have to be the same bases. That's really important. So, but let's just look at this maybe from a 5th grade standpoint. No insult intended. How about this one? 5 to the first power over 5 to the second power could be simplified as 5 over 25, couldn't it? Which would be 1 over 5, right? I'm just simplifying this out. Is that okay? All right. So hopefully you're buying that. If we use here, now, I think that makes sense, right? 5 over 25 is 1/5. But if we use this rule right here, and we apply this rule, and I want to be clear with you that these rules are based on patterns of arithmetic. Nobody made up the rule and then tried to make the math fit it. They found patterns, like what is always true? Or what is true almost all the time, and can we define when it's not true? So this, I think, is true. So let's look at this now. Let's use this rule up here. So we have same bases, they're 5, and we have to the first power here and to the second power here. Remember that arithmetically, we've already solved this, and we know that the answer has to be 1/5. But when we get 5 to the m minus n, so to the 1 minus 2. And wouldn't that equal 5 to the negative first power. And my only suggestion to you is arithmetically, we know that 5 to the first power has got to be this. So what do we do here? We rationalize this, and we talked about at the very beginning of the video. We rationalize this, and look, to make this 1/5, here's the 1 here. Here's the solidus, or the fraction bar, if you will, here. And all I'm doing to make this work is to make this conform to the pattern of arithmetic is flipping this over, right? And we get, check it out, 1 over 5, not to the it was to the negative 1, wasn't it? But we cured it. Now it's just to the 1. This is not voodoo or magic or anything mysterious. We're trying to make rules for math, simplify things, but they have to follow the patterns of arithmetic. So all I'm saying is this just follows the pattern of arithmetic. You're saying, well, why wouldn't I just do it this way? Well, what if you had 5 to the, I don't know, 13th power over 5 to the 15th power? That's a lot of arithmetic to do, isn't it? But if we use this first rule here, we have 5 to the 13 minus 15 is 5 to the negative 2. But we know that to fix this, to correct this, to cure this negative exponent, we're going to use this little trick here. Why are we using the trick? Just to make it fit the pattern of arithmetic. We're just going to flip this thing over. And it would be, it would be 1 over 25, 1 over 5 squared, right? Which is the same as 1 over 5 squared. So I hope you're buying some of this. There's no perfect proof. There's good proof. There's good evidence. And some of you have to buy, and what I'm asking you to buy, I guess, the most of is that what we're really doing is investigating patterns of arithmetic. This is not new math. And it's kind of cool. Like you take it home and show it to people who are not into math. You show them this, and you're like, wow, what? No, this is just arithmetic. Or you show them this, and you're like, what? No, it's just arithmetic. So it's all just arithmetic. Don't take it too seriously. When you get confused about it, test it. Test it with some simple numbers and see if that doesn't come out to be true. All right? All right, good work.